In this lecture, we are going to solve a problem on series magnetic circuits. The question is, an iron ring of mean length 60 cm has an air gap of 2 mm and a winding of 300 turns. If the relative permeability of iron used in the ring is 400, when a current of 1.5 ampere flows through it, find the flux density. Okay. So an iron ring of mean length 60 centimeter. So we have considered an iron ring having a mean length 60 centimeters and it is having a winding of 300 turns. So a winding of 300 number of turns is wound over this iron ring. So 300 turns are there in this winding and the relative permeability of iron is given as 400, and when a current of 1.5 ampere is flowing through the coil, we have to calculate the flux density in this coil. So mean length of iron ring is given. So length of this iron ring is given as 60 centimeter. So we can denote length of iron as Li and is given as 60 centimeter. Then there is an air gap of 2 millimeters. So here in this iron ring there is an air gap. So this can be that air gap and it is having a length of 2 millimeters. So this is 2 millimeters. So we can write the length of air gap Lg is equal to 2 millimeters. Then the winding is having 300 turns. The number of turns N is equal to 300. Then the relative permeability of iron, that is mu R, is equal to mu R for iron is 400. The relative permeability for iron is equal to 400. The current is given as 1.5 amperes. So we have been asked to calculate the flux density B. Okay. So this is a series magnetic circuit. There is iron path as well as air path. So we can consider this as a series magnetic circuit. Okay. And we have to calculate the flux density in this series magnetic circuit. So we know that in a series magnetic circuit, the flux will be same everywhere in the circuit. Flux linking with the entire circuit will be the same and flux density will also be the same because area of cross section of iron ring as well as the air path will be the same. So this is our air path. So area of cross section of iron ring and the area of cross section of the air path are the same. So flux and area of cross section are the same. So flux density will be same in the iron path as well as in the air path. So we have to calculate the flux density in this entire circuit, in this magnetic circuit. Okay. So we know one equation for flux density, that is flux density is equal to flux divided by area. So if we can calculate flux by some means, then by dividing that flux by the area of cross section, we will get the flux density. But see, in this question, the area of cross section of the iron path or the air path is not given. So we cannot use this particular equation for calculating the flux density. So we have to use some other methods for calculating the flux density. Now, this is a series magnetic circuit and we know that in a series magnetic circuit, the total MMF is used for setting up flux in the iron path as well as in the air path. So among the total MMF, a part of the MMF is used for setting up flux in the iron path and the remaining is used for setting up flux in the air path. So we can write total MMF is equal to MMF of iron path mmf of iron path plus mmf of air path. Okay, so here total mmf will be equal to mmf of iron path, mmf used up in the iron path plus mmf used up in the air path. So it can be written like this, and in case of every magnetic circuit, the total mmf can be calculated as the current into number of turns of the coil wound over the magnetic material. So total mmf always equals the current into number of turns. That is 300 into 1.5, that becomes 450. Total mmf is 450, and now we need mmf of iron path and mmf of air path. Okay, so how will you calculate mmf of iron path? We know the magnetizing force H is equal to Ni divided by L, that is mmf divided by length. Now by using this equation, mmf can be written as H into L. mmf is equal to the magnetizing force H into length of the magnetic path. So we can write mmf of iron path as magnetizing force of iron material into length of iron path, Hi into Li. So we can write mmf of iron is equal to Hi into Li. Plus similarly mmf of air path can be written as magnetizing force of air material into length of air gap, that is Hg into Lg. Okay, now by solving this particular equation, we will be able to calculate the value of flux density B. Okay, see. So we got 450 is equal to Hi into Li plus Hg into Lg. Now what is Hi? So we know that H is the magnetizing force, and we know a relationship between the flux density and the magnetizing force. Okay, so we know that B is equal to mu into H. So H can be written as B divided by mu. So now we will be representing H in terms of B, because we need to get the value of flux density B. So for that we will represent H in terms of B. So H is equal to B by mu. So we can write this equation as 450 is equal to Hi, that is magnetizing force of iron, will be equal to flux density divided by absolute permeability of iron. Because as flux density is constant, flux density is same in both iron as well as in the air path. So we can use B. We don't have to use Bi and Bg. Bi for iron path and Bg for air gap. Both are the same. In a series magnetic circuit, flux as well as flux density are the same if both the magnetic materials are having the same area of cross section. Okay. So here the flux density will be same in iron as well as in the air path. So we can use B. So Hi can be replaced as B divided by, Hi is the magnetizing force of iron. So B divided by absolute permeability of iron, okay, into Li, length of iron path, plus Hg. Hg is the magnetizing force of air gap. So it can be written as B divided by absolute permeability of air gap. So B divided by absolute permeability of air into length of air gap, that is Lg. Okay. Now that becomes 450 is equal to, B is common, so we can take B common outside, into Li, length of iron is 60 centimeter. So 60 centimeter, it should be represented as meters. So 60 into 10 raised to minus 2 divided by mu of iron. Absolute permeability of iron is equal to mu 0 into mu r. permeability of free space into relative permeability of ion. We know that absolute permeability mu is equal to mu 0 into mu r. So mu 0 is 4 pi into 10 raised to minus 7 into mu r. Mu r for iron is given as 400. Okay, into 400 into, okay, B by mu. B into Li divided by mu. So Li divided by mu is mu 0 into mu r plus Lg divided by absolute permeability of air. And length of air gap is 2 mm. So 2 into 10 raised to minus 3 meters divided by absolute permeability of air. That is mu 0 into mu r. So 4 pi into 10 raised to minus 7 into mu r. Relative permeability of air is 1. So 1 into, okay, 1. Now here there is only one unknown, that is B. So by solving this equation we will get the value of flux density B. Okay, this will be B into, on solving the first term we will get the answer as 1193.6620. 1193.6620 plus the second term will be equal to 1591.5494. Okay, so 450 is equal to this much, and by solving this we will get the value of flux density B as 0.1615 Weber per meter square. Okay, so we will get B by dividing 450 by this term. 450 divided by this term will give us the value of B, and that is equal to 0.1615 Weber per meter square.